Okay, so this hopefully will be the last video. Now, I want you to think about this here. We have a denominator, so we're going to have a problem at x equals what? -1. When we differentiate this, you're probably going to be using who? Quotient rule. So one thing we are not allowed to use is x cannot be equal to a what? A -1. Otherwise, this guy's undefined. So that means we immediately have to break everything up into what? Two regions. One to the left of -1, one to the right. Next step. Quotient rule. Bottom derivative of top minus top derivative of bottom all over the bottom squared. Simplify all this. Okay, so I'm not going to bore you guys. It's the same old stuff. Do your cancellations. Now, your first derivative, notice it's a fraction. When is a fraction equal to 0? When the numerator is equal. 1 is not 0, so in other words, there's no critical points in the sense that the derivative is equal to 0. Critical points also occur when the derivative is undefined. That also occurs at x equals -1. So the only critical point we have is at x equals -1, and we're not going to have a local max or a min. So let's move that up. So what do? We have a critical point in the sense that the derivative is not defined at -1, means we separate it into two what? Regions. To the left of -1 and to the right of -1. So what's my test point going to be in region 1? How about a -2? What's my test point going to be in region 2? How about 0? And that's all we're doing here. In region 1, I'm going to choose a -2. So I put in a -2 plus a 1. I square the number. Please, I don't care what the number is. All I care about is the derivative positive or is it negative. Positive, which means the function is going up. The original. Next step, I pick a test point. 0. 0 plus 1 squared is a positive number. Positive, which means it is going up. So h prime is not 0. So in other words, what's happening is it's increasing and increasing again. Now, later on in the semester, we're going to find out that the graph of the h actually looks like this, and this is going to be called a vertical asymptote. So here's an example where you do not have, you have critical points because the derivative is undefined, but there is no local max or min. Next one. Now, can I make the denominator ever 0? No, because the worst that this could be is 0. This is positive. So I don't have to worry about the derivative being undefined. So x could not be, right, there's no value of x. When I square it gives me a -1, unless we talk about complex numbers. So it's the same old stuff, folks. I'm not going to bore you. This is the quotient rule. Bottom derivative of the top minus the top derivative of the bottom all over the bottom square. Do your, now you're going to have to actually simplify things. And we end up with this guy. Now, that's going to be our derivative, right? And notice that the denominator, there's no way I can make that denominator 0. So we are going to be able to set the numerator equal to 0, though. So we don't have to worry about a critical point being the derivative is undefined. So I'm going to set the derivative equal to 0. This is a fraction. When is a fraction 0? When the numerator is 0. So in other words, I set 1 minus x squared. Now we're not going to go through the long division. This is just a difference of two perfect squares. It means either x is 1 or x is equal to -1. In other words, we have what? 3 regions here, right? We have in here, here, and here. So I'm going to have to pick test points. Test point here is going to be 0. Test point here is going to be 2. Test point here is going to be -2. Okay, now what I'm also going to do is I'm going to let's rewrite the derivative this way. Now, the denominator, I don't even have to worry about this because this is always going to be a positive number. So I really only have to worry about those two. So, all I have to really worry about, this is always going to be a positive number, so all I have to do is look at the sign. Remember, we're trying to be lazy here. I don't want to do unnecessary calculations. So for my test point of -2, I'm going to just put it into here. That's all I care about. So if I put in a -2, again, don't tell me what the number is. This is going to be a negative number. Minus a minus is plus. This means a minus, which means it is decreasing. Now I pick 0 as my test point. Don't even waste your time with this. Put a 0, put a 0. Positive, 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 which means it's increasing. And the last is in region 3. I'm going to pick my test point to be 2. You put in a 2, you put a 2. Don't tell me what the number is. Positive, negative, positive, which is negative, means it's decreasing. So what that means is negative, decreasing, increasing, decreasing. And how do I figure out what this actual min is? I take my I take my x value and I put it into my original function. So you're going to take your critical point and you're going to put it back into here. And you're going to ask yourself the question, what is the value of that? Excuse me, h. Where did h go? Oh, I'm sorry. I started calling it different functions. H, F. Somehow I switched them. This should really be an F. Okay, so just dump in your -1 and your 1. Those are your critical points. So you have a local, min at -1, and its value is -1/2. You have a local max at 1, and that local max is 1/2. And yahoo, we got through the first section.